We're going to go ahead and take a look at what happens when we have two quantitative variables and how we can visualize that and display it. And then we'll look at being able to summarize that. Now we're going to look at direction of association. Two variables are positively associated if as one variable gets higher, the other variable gets higher, or as one variable gets lower, the other variable gets lower. Two variables are negatively associated as if one gets higher, the other gets lower, and vice versa. And then sometimes two quantitative variables are not associated at all. In other words, what one variable does has no effect on what the other variable is doing. So at the top here, we have some quantitative variables. At the bottom, we have some possible ways we could pair these up. We could take a look at the weight of a car versus the miles per gallon in the city, the weight of the car versus fuel capacity, or the page in Consumer Reports compared to the fuel capacity, or the weight versus a quarter mile, or acceleration in from 0 to 60 versus a quarter mile, or miles per gallon in the city versus a quarter mile. So at this point, I'd like you to pause the video and take your guess on how strongly you think these are associated and whether positive or negative, and use kind of the words on the scale down below. Now we're going to come back to this, so you'll get your answer shortly here. Now a scatter plot really is just the relationship between two quantitative variables. So this one here would have somebody that studied 70 hours and their GPA, which is about a 3.8. This one here would be somebody that studied about 8 hours and had a GPA of about a 2.6. Now, if somebody studies 20 hours, you'll notice there's lots of people that studied 20 hours going straight up and down here with different GPAs. So each point represents one paired set of data of two quantitative pieces. So here we have those things that you're asked to figure out the correlation for before. Now this one here, when we looked at our miles per gallon versus the weight, miles per gallon in the city, as that increases, our weight decreases, which you might expect. We would say this is negatively associated, and I would say it's a moderate negative association. This one up here, oh, sorry, is positively associated, and I would say moderate because we're going up. This one here, I would say is like a weak negative. This one down below would be a weak positive. This one here in this bottom center would be a very strong positive association. And this one over here is just kind of a bunch of random points, no association whatsoever. Now, correlation is really the measure of the strength and the direction of a linear association between our two quantitative variables. The strength, or the direction I should say, if it's positive, it goes up as it goes to the right, and as one increases, the other increases. If the direction or correlation is negative, the direction goes down as you go to the right. So as you go over on the x, your y goes down. It's negative association. Correlation for your sample is referred to as R. If you're dealing with correlation for your population, that is rho. So let's take a look here. Up here, this associate or correlation is negative 0.91. As we move over here, this is positive 0.98. This one is negative 0.45. This one over here is negative 0.08, really close close to 0. This one here is 0.99. This one over here is 0.51. So what are some of the properties of correlation? Well, all the values for correlation are always from 1 to -1. If it was perfectly straight and on a line, it would be +1. If it was perfectly straight and on a line going down as you go to the right, it would be -1. So the positive R's are the positive association going up as you go to the right. Negative R's are going down as you go to the right. Correlation of about 0 has just kind of random points and no association. The closer R is to 1 or -1, the stronger the linear relationship, and the points are closer to a line. R has no units and really depends on, uh, it's not dependent on the measurement or the units that you are measuring. Now, if you look at the correlation between X and Y, and then you switched X and Y around and plotted it, it would be the same correlation. Take a moment here to try to figure out what would be the appropriate correlation for each one of these. Now, you notice the two on the left are both negative because they're going down as you go to the right. The top one is not spread out as much, so it's got to be closer to -1, so it would be 0.98. The bottom one is spread out just a little bit more, so it's a -0.99. As we look on the ones on the right, they're both going up as you go to the right. Now, I would say the points in the top one are a little bit closer together. If you put a line through the middle, it would not be spread out as much. So that's got to be the one that's a little bit closer to 1, so 0.72. So this one down here is positive as you go to the right, but still spread out a fair amount up and down. That's the 0.61. So here we have a situation where we're looking at NFL teams and how many yards they're penalized on based on related to their uniform. So R is 0.43. It says it's a positive association. Now, keep in mind, up here we have somewhat of an outlier. Down here we have somewhat of an outlier. We have our Oakland Raiders up here. We have our Miami Dolphins down here. If we remove those two outliers, we get an R that looks about like, or a scatter plot that looks like this, and R is about 0.08. In other words, if we remove the two outliers, there's really no association whatsoever. So correlation is heavily affected by outliers. So always plot your data and look for those. So suppose we have the human cannonball. We're looking at our angle of the cannon, and then we're trying to shoot over and land on a mat. So plot your X versus your Y. Plot your angle compared to how far you're able to go. And just see if you can plot that out. So is there a relationship between X and Y? Yes. But our correlation is about 0. Are they associated? Yes. Correlated? No, I misspoke in that. There's a definite pattern going on here, but they're not dealing with correlation because correlation only works with linear data. If your data is curved, you cannot find R. So looking at this one here, we looked at this earlier in the course, where as the number of TVs increase, the life expectancy increases. So is there correlation here? Yes, but correlation does not imply causation. So when we're dealing with two categorical variables, we want to create a scatter plot, and then we want to look at our correlation.